Hi students, in this session we are going to discuss on the topic system metrics. System metrics is a matrix which encompasses the total change of a ray. That is, when a ray passes through, for example, a double convex lens, refraction occurs twice between the two curved surfaces and translation occurs once between the two curved surfaces. So I'll show you the figure when we consider refraction. Um, Here, the ray, it first undergoes one refraction at the first refracting surface, then it undergoes a translation between the two ends of the lens, and then again it undergoes one more refraction. So, the system matrix here must consist of two refraction matrices and one translation matrix. So, such a system matrix only will be able to contain all the operations through which our ray will undergo. Okay, so a system matrix is a matrix which includes or incorporates the total change in our ray. So, in the case when a ray passes through a double convex lens, there must be two refractions and one translation taking place. So, we require two refraction matrices and one translation matrix, and the product of all these three form the system matrix in this case. So, let us see how we can write the system matrix exactly. So, if x1 lambda 1 represents the incident ray and x1 dash lambda 1 dash represents the refracted ray inside the lens after the first refraction. So, first refraction is taking place, then translation is taking place, then the second refraction is taking place. So, x1 lambda 1 represents the incident ray and x1 dash lambda 1 dash represents that ray after refraction. So, x1 dash lambda 1 dash is obtained when the refraction matrix operator acts on x1 lambda 1. Okay, so we have already learned the expression for the refraction matrix. So we can write x1 dash lambda 1 dash is equal to r1 into x1 lambda 1. What is r1? It is 1, 0 minus p1, 1. Matrix 1, 0 minus p1, 1. Where minus p1 is mu1 minus mu2 by r1 into where mu1 is the refractive index of the medium through which the ray passes first. If it's air, it is 1 minus mu2, the refractive index of the lens. So, 1, 0 minus p1, 1 into x1 lambda 1 is the will give us x1 dash lambda 1 dash, that is the ray after first refraction. Designation of the ray after first refraction. Now, this ray x1 dash lambda 1 dash undergoes translation. Okay, to form say x2 dash lambda 2 dash. So x2 dash lambda 2 dash will be equal to x2 dash lambda 2 dash is equal to translation matrix into x1 dash lambda 1 dash. That is x2 dash lambda 2 dash is equal to T221 x1 dash lambda 1 dash, that is equal to the translation matrix is given by 1 d by lambda d by mu 2, that is translation takes place through a homogeneous medium. Here translation is taking place through the lens. So it is the refractive index of the lens that you have to write here. So 1 d by mu 2 0 1 into x1 dash lambda 1 dash. Now refraction at the one more refraction has to take place, that is at the second surface. So if x2 lambda 2 is the designation of our finally refracted ray or the final ray after second refraction, then x2 lambda 2 is equal to r2 into the result that you obtained after refraction, the result that I obtained after not refraction, after the translation. So it is r2 into x2 dash lambda 2 dash. So my final refracted ray x2 lambda 2 is equal to r2 into x2 dash lambda 2 dash. Now what is r2? R2 is equal to 1 0, P2 into P minus P2 and 1. Now the combined equation can be written as x2 lambda 2 is equal to 1 0 minus P2 1 into, you should write x1 dash lambda 1 dash. No, x2 dash lambda 2 dash. Now what is x2 dash lambda 2 dash? It is this product. So I am replacing x2 dash lambda 2 dash with this one. 1 d by mu 2 0 1 into x1 dash lambda 1 dash. What is x1 dash lambda 1 dash? It is r1 into x1 lambda 1. So what is r1? 1 0 minus p1 and 1. So I can write all the three matrices here, that is second refraction, translation, first refraction into x1 lambda 1 will give me x2 lambda 2. So x2 lambda 2 is equal to r2 into t21 into r1 into x1 lambda 1. Now the product of these three matrices is called the system matrix. Okay, it encompasses all the changes, or the total change in the ray will be given by this matrix. Okay, the product of these three matrices. So S is equal to R2, T21, R1. Next, what we do is matrix multiplication. You multiply from right to left. That is, first you multiply these two matrices, then its answer is multiplied with this matrix, so that you get the result in this manner. So the system matrix for the case when a ray passes through a double convex lens is given by 1 minus dp1 by mu 2 d by mu 2 minus of p1 plus p2 minus dp1 p2 by mu 2 into 1 minus dp2 by mu 2. Here mu2 is the refractive index of the lens and capital D is the distance travelled by the ray inside the lens. That is the translational distance covered inside the lens is D. So we got the system matrix. Again, I find out the determinant of the system matrix. You will get it as 1. The system matrix can also be written in terms of ABCD as S is equal to C minus D minus A and B, where A is equal to P1 plus P2 minus D P1 P2 by mu 2, B is equal to 1 minus D P2 by mu 2, C is equal to 1 minus D P1 by mu 2, and small d is equal to minus D mu 2. Here B and C are dimensionless, whereas small d has the dimension of length. All these A, B, C, D are called Gauss constants. So I think the representation of system matrix, how do you get the system matrix for a particular case is clear to all of you. If you have any doubt, please do contact. Thank you.